Okay, I'm going to be talking about tincture doses. I brought up in previous lecture, oh, weights and measures and the apothecaries uh, scale, right? Or apothecary scale, apothecaries weight. Basically, measure very expensive chemicals in the laboratory to a high degree of precision and accuracy so that you don't waste money. On top of that, the scientific method should be, well, the scientific method can stay as it is, but if you look into the scientific method, basically you think a lot, then you plan an experiment, and then you do the experiment at the very last, right? You actually do the experiment where you purchase chemicals and you wait and you spend money on your experimental design at the very last step because um, you have to do the literature search and come up with a very, a priori calculations whether or not, if it's a chemical system, if it can proceed based on ab initio calculations or not. You look at literature and sometimes they show certain mimic to your structural design that may look like it can go, but unless you make models of steric approaches and so on and so forth before you actually start purchasing all these expensive chemicals to add to the experiment, you may, the 50-50, it ain't gonna work at best. Usually in empirical science, if you're correct 50% of the time, everybody thinks you're very, very, very successful in the laboratory. There's a lot of things that can go wrong in the laboratory that are fairly inexplicable, and the literature doesn't show failure, it just shows success. But failure happens at least 50% of the time in a test tube. Nevertheless, I mean, the reason why you go about meticulous experimental design is to avoid the waste of resources and money, right? That's why at the very last step is the actual performance of the experiment. There's an eight. I think the scientific method consists of 8 parts and subsections to each part before you actually start purchasing things. Anyway, with that said, here's the tincture dose, right? It's small therapeutic doses in medicine. For example, here's the apothecary picture that came up on the Autobot from PowerPoint, but you get the picture, right? There's herbs that are very expensive inside a bottle that they sell to crazy ladies or people that just like this kind of thing, right? They dissolve this and maybe a little bit of alcohol and they put it out in the sun, and the essence of this herb goes into the alcohol. They drink the alcohol and the essence of the particular herb. It could be rosemary, it could be ginger, it could be frankincense. Turns out that frankincense is very expensive. I'll show you what I'm talking about. It is frankincense oil. The essential oil is fairly inexpensive, but the chemical, the boswellic acid, if you want to buy a certain small amount of it, is very expensive in the Aldrich catalog. Okay, here's the Aldrich catalog, $600 for, I think it's 10 milligrams. So it's a very small tincture dose, and this is the triterpenoid structure of the plant, frankincense. I think it's in northern Africa. It's a very, very abstruse plant to grow in a certain zone, but it's here, right? This is a boswellic acid extracted from the frankincense itself. And this is a business end. There's a myriad of boswellic acids that have different structures associated with the side chains, but this is a very expensive derivative, right? Isolate. $600 for just 10 milligrams of this particular boswellic acid, right? Very expensive. That's what I'm talking about. Okay, here's a tincture, okay? You have one of these nose droppers. This is 4.2 milligrams. twice as much, 8.3, 12.5, 16.6 milligrams in a 500 milligram tincture, because it's mostly in an aliquot of a solvent system. Could be, oh, vodka or something. This is CBD. I don't know if I should. This is just what came up. CBD is cannabis in the medicinal structure of what is medicinal doses of the tincture of cannabis, right? That's what they're talking about. Here you have 1,000 milligrams. It's a lot more. Could be. Let me see what they're talking about. Yeah, it's like twice as much, right? Yeah, twice as much. They're talking about the aliquot, and they're talking about the actual chemical that's dissolved in an aliquot of solvent, right? So anyway, I just wanted to impress upon you how small these things are. 8.3 milligrams is like cigarette ash. It weighs like 8.3 milligrams. Like when you have a cigarette and you smoke, and you have an ashtray, and like every time you smoke and you drop the ashes in the ashtray, like that one time, that ash weighs in particular like from 8.3 milligrams to about 16 milligrams or so. It's like a real small amount. If you dissolve that cigarette ash in a quart of milk, it's so many parts per million. Like if you have 8.3 milligrams in a liter, it's 8.3 parts per million. If you have 16.6 milligrams in a liter, it's 16.6 parts per million. Basically, a milligram per liter is a part per million. So basically, a part per million is roughly, what a cigarette ash from a cigarette in a cigarette ashtray dissolved in a quart of milk would be about. You can probably even discern the taste if you're good. You have good taste buds. Anyway, here you go. Here you go. Yeah, that's CBD. That's cannabis. Turns out that it has no basic nitrogens. As a chemist, I always look out for the structures and the business end of what makes it so potent and herb, right? It actually has no basic nitrogens. It has a very cute stereo structure that fits into a pocket into the receptor sites. But that aside, there's no basic nitrogens here, okay? Okay, basic nitrogens and alkaloids are very addictive. They're very dangerous. A lot of alkaloids are very poisonous. Here you have strychnine, that's rat poison that was used back in the day. Here you have morphine, that's what's in heroin. Here you have, I can barely see it, but I think this is quinine from the bark of some tree, and so on and so. Here you have epinephrine or ephedrine, that's in ripped fuel, that stuff that gives you that when you lift weights and you want to get ripped. Ephedrine is ripped fuel. It's very bad for your heart, right? It's very potent, very addictive. This is nicotine. It has a basic nitrogen right here. That's why cigarettes are so addictive. This has a basic nitrogen right there. See it? sp3 hybridized nitrogen. That means this is an sp2 hybridized nitrogen because there's 1, 2, 3 minus 1 sp2. Here you have 1, 2, 3, and there's a lone pair of electrons, so that's 4 minus 2 minus, well, it's sp3, right? You have 1, 2, 3, the lone pair of electrons. 4 minus 1 sp3, right? This is you have 1, 2, and the lone pair of electrons is 1, 2, 3 minus 1 sp2, right? sp2 nitrogens are very innocuous. They're in proteins, they're in peptides, peptide bonds, caffeine. Most of that's sp2 hybridized nitrogens, and caffeine. It's not really all that addictive. I can go out. I don't like being without my coffee in the morning, but it's not as addictive as a cigarette. Okay. Here you have tincture doses, poise and poisons, right? Poise is actually a viscosity measurement that if you have a high poise, it's so many dynes per centimeter that some liquid can move. If it's very viscous, you have the poise value is affected, right? I like to think of poise as poison because you ain't gonna be eating no grease or nothing like that. Anyway, poison. I just make this cute analogy. I don't know if it's really appropriate, but basically you have tincture doses that are very low, right? There's a reason for that because a lot of these medicines are very addictive and dangerous. Like here you have morphine, strychnine, quinine, ephedrine, and nicotine. I mean, I don't know if any of you. Hopefully, you'll never be addicted to any of these things, but nicotine in cigarettes is very addictive. Okay, so it's addictive and dangerous. You can overdose on some of these compounds. They're very dangerous, very poisonous, right? Tincture doses, it's in weight, so it's usually milligrams per dissolved in a solvent system, usually ethanol. So, or if it's a herb, it's usually an ethanol, right? So, anyway, I just brought this slide up to show, first of all, from the original apothecaries doses and how expensive some of these chemicals are, and also bring up the difference between a tincture dose and a dangerous dose. Dangerous dose is like in the grams, tincture doses is in milligrams. So let's say you have 8 grams or a huge amount of substance that you're ingesting at the time. You could actually die of nicotine poisoning if you have so many grams in your bloodstream of this stuff. It's dangerous. I mean, a cigarette, when you smoke, it doesn't really give you that much. It gives you a nicotine hit, but when you measure it out, milligram tincture dose versus grams, which is like stoichiometric amounts, right? It's very dangerous. Tinctures, for example, in this book written by some chemist in Japan, that there was a study in the morphology of crystals in water. Like he studied snowflakes, he studied water, right? Rainwater, for example, because the water that comes out of the tap has a lot of chlorinated substances and a lot of minerals that prevent it from having a memory. The memory is what the tincture dose was alluded to. If you have a certain small amount of substance in your body that's mostly made up of water, I think it's about 70 to 80% water is what your body's made up of. If it has a communication relay, like the water has memory, right? That says through the hydrogen bond network. The hydrogen bond network is disrupted with the addition of chlorine and iodine and all these things. But let's say they didn't have that stuff, right? If you didn't have that stuff, you'd have communication relays of hydrogen bond networks throughout your body. So if you had a tincture dose with a certain amount that would hydrate it within the serum, you would have less amount of poise or poisons in your body, so that you'd minimize the amount of medicine. So maybe instead of parts per million, you'd be in micrograms per liter, or something like that. I think yeah, parts per billion, but I don't know if it goes down that microgram per liter is basically what a lot of fluids and minerals and vitamins in your body are already about. So you basically that aspect of what is concentration within the serum for therapeutic purposes is distinct between tincture and addictive and dangerous. Addictive and dangerous is by definition what these medicines are, right? Nevertheless, it can be used for therapy, for therapeutic purposes in the appropriate doses, given the appropriate time-release capsules that are given to you through the apothecary pharmacy under controlled environments, right? Okay, that's about it. Goodbye.